Hey physics peeps, I'm coming to you today from my basement. And I just wanted to give you a heads up on a few things. One is great job doing the Go Formatives. You all have been doing really great. Make sure that you complete everything that's on there and give your best effort in answering the questions. I'll try to give you feedback on that each day. And then make sure that you ask me questions if you have questions about anything. You're not sure about how to answer something, or if you can't find something else, shoot me an email, or you could even leave a little feedback on the question itself, and I'll get back to it and try to get you an answer for it. But really wanted to talk about two questions that were on the last Go formative on static electricity. This question where it asked you about Natasha that was running a soccer practice. In that scenario, she ended up gaining a charge at one point and then discharging at another point. You were asked these questions like, how did she become charged and how did she discharge? A lot of you had really great answers for them. I do want to clarify something with the charge and discharge, because really when we gain and lose charges, we're talking about electrons. Electrons are how we gain and lose charges. Nothing else, not protons, neutrons, or the whole atom itself. Usually we're just talking about electrons. We can kind of think of it like this scenario where Natasha is running across the carpet. It's like John Travolta here. He's going to shuffle his feet across the carpet. When he does, he actually picks up electrons. So with the example with Natasha, she gains the charge by shuffling her socks across the floor or shuffling her feet across the carpet. And so we pick up electrons and they spread out around our body, and they spread out because electrons don't like being next to other electrons. They repel each other because they're the same charge. They'll stay on us until they get close to something where they can spread out even more, or get off of our body, because there's excess electrons on our body now. And so that's where we say we discharge. We can discharge in a lot of different ways. We can discharge really by touching a conductor. A lot of you have done that by touching like a doorknob or a chair or somebody else. You could end up getting those electrons to move away from you if that force is strong enough. And we get that electric shock. And in the case with Natasha, she ends up discharging by touching something particular, another conductor, and that's the faucet. But it's the faucet in particular because in our house, we actually have something that is connected to all our water pipes. You might remember this from the Bill Nye video. If you go in your basement or if you go in your apartment, you could actually find certain places where there are bare wires that are going across, like floorboards or running in the basement or even running to the outside. But that bare wire, what it connects to is your water pipe. And this is the water pipe that comes to our house from the city, and it goes all the way into the ground. But that ground wire, bare wire, actually follows it directly down into the ground. That's why it's called the ground wire. It's a place where electrons can actually spill off instead of kind of like in the case with John Travolta. We have electrical appliances that really do the same thing when they run for a long time, like refrigerators or blenders or other appliances that we have. If they build up too many electrons, they can actually start on fire. So to prevent that, they actually connect it to that ground wire where these extra electrons, they can follow the ground wire into the ground, where they can spill out and safely go and not cause fires. That's kind of it. Cool beans. So hope you all are doing well. We miss you guys. And make sure that you're doing something fun each day, like, and maybe learn something else, like play cards with your family or something like that. But let me know if you have any questions. Again, have a really great day. See you guys.